Get very good at remembering to hit record buttons. Share screen. Fusion. Can everybody see the Fusion screen?
Yes. Yep.
Excellent. Don't know. There we go. Someone can see that. Okay. Before we get started, was any questions from the last couple of sessions, or has anybody kind of had a go at modeling some of this or any other models? So.
Hey, Michael.
Yeah.
The right side of the Gonk, that area that has all the greeblies and everything.
Yeah.
I actually modeled that as one piece and just inserted it into the Gonk instead of it being in piece. I just did one big piece and just slid it in.
Okay.
Yeah, it worked out okay. I'm just trying to do different things as I learn, but it seemed like it worked out okay.
Is that the piece on the right hand side? This kind of detail here.
No, the right hand, the right hand Gonk, the facing
this one.
Yeah, that whole circle area. Yeah.
Right. Yeah, so you just did that as one big insert.
Yeah, and then I just slid it in and out. I don't have it up right now. Something wrong with my Fusion, but it seemed like it worked okay.
Yeah, it's to be honest, it's probably something I'd do that because it's ideal if it's printed flat, isn't it? You've not got to compromise as much trying to put angles in to get overhangs and whatever.
Right. Yeah. And I'm going to put magnets around the outer shell. So I'm going to put some lights and things behind it. So I have it as one piece. And then if I want to get inside of it, I can just pull it out and do whatever.
No, perfect.
Ah.
Cool. Anybody struggle with anything on the modeling so far? Are we all kind of all make sense and all working? No.
No, all good.
I'll take that as a very positive then, really, to be honest. Cool. Okay, so what I have done is just in the last half an hour or so, I've just added this greeble at the front. I wasn't going to step through how we did that. It was pretty much the same as we've done already, which is using pulls and extrudes, etc. So effectively, again, we talked about sketching on different surfaces. So you can sketch on this surface here. You can pull it up so that it front and it lines up, and then you can start to draw some of these different greebles and different sort of shapes, and then really just use either the extrude or the pull to continue to sort of add details. One thing to watch, I'll just go through some 3D printing stuff, to be honest. One thing to watch is first of all the size of some of the details on here, bearing in mind that depending on the scale that you're printing it on, you're going to be printing on a .4 nozzle. So I find the inspect button really useful because I can quickly, and you tend to lose scale anyway between when you're zooming in and out, everything looks a lot bigger than it actually is. So you can measure between two lines there. So I can see that's 1.93 millimeters, for example. On the .4 nozzle, that would be fine. But if you're getting down to sort of 0.1 and 0.2 millimeter details, you will lose them. I tend to find things like the body panels and the R2 on R2 where I'm putting lines in there. I'll go down to probably about 0.6 millimeter to make the details around the panels. I won't go much below 0.6 because otherwise it just you just lose the detail when you start to print it. And as soon as you start to paint it, it just kind of fills in. So it's really not kind of worth going down to that sort of level. The other thing that I tend to do is, and again, this is more direct modeling, but I just tidied the sketches up. I literally just delete all the sketches, like I've just done there. I'll delete the actual constructs of planes, just so that all I'm really left with then is the bodies, and it just makes life a little bit easier I've not got a huge list of things really on here. Obviously, if you're not doing direct modeling, if you're using the timeline, you can't do that because everything's linked. Whereas with direct modeling, as I said a few times, it's a bit like wood, to be honest. You can just go back and change and cut bits and then rejoin bits. Right. So one of the things I was going to cover, I covered this very slightly last week, is how you do these tubes, which or cables or whatever. So I did a lot of these on choppers' legs as well. So, and I think I did cover it. But what you're looking at, let me just bring my origin back. There we go. So the way that you do these is something called sweep, and sweep again a really useful tool. What you can do is if you just go to the front, but what sweep requires, it requires 2 sketches along 2 different planes. So I'll just show you in simple terms what that does. So that's the shape of my cable, wire, or whatever I want to sweep. So I finish sketch, and then what I'm going to do is define the path that sketch goes. So again, I'm going to choose a plane that's 90 degrees to that. I'm going to use a spline because that gives me a nice smooth curl, and I'm just going to draw a little bit of a cable like that and tick. Okay. As we said last time, that's you can get the cable moving on a spline, but it's still really in 2 dimensions. So if you look at it directly from the side, it's still flat. Now, what you can do then is go in and edit the individual points. And again, I think we covered this a little bit. I just want to refresh on this here. So I can then look at it on the flat line and I can pull that down a little bit. And I can click on that, pull that up a little bit. I can click on that, pull that down a little bit. So what I'm starting to get now is this shape in sort of 3D space. So if I look at it from the side, that's what it's like. If I look at it from the front now, you can kind of see that it's got this loop thing going on. So you always draw it in 2D flat space, and then you move that. So what I've got now is I've got a profile here, and then I've got a path which is going to follow the profile. And the 2 do need to intersect. And then finish sketch, and this is where you do the sweep. You highlight that profile, you click on the path, click on there. And what it then does is it will actually do your cable like that. So sweep, I find sweep really useful for doing that. The other thing I do use sweep for sometimes is for adding overhangs after I've made a complex body, particularly on curves. But I can show you what I mean on here. So if I was printing this straight up, I've got a 90-degree overhang here, which would create me a bit of a problem. So what I'll often do is create a mid-plane, say between there and there. Click OK. And then what I'll do is I'll draw on that mid-plane. It'll all become apparent in a minute. Sketch. And what I'll do is for reference, I'll reference that line and that line. They're the ones that I want to kind of create a little bit more of an overhang. And rather than being 90 degrees, I might just pull that down to, so that's 180 to 160, which is 20-degree overhang, which is, as I said to you before, that's probably the sharpest that I would actually go. So what I've done now is I've created a profile. Oops, let's have a look. So you can see the profile I've created. I want to add that now. So what I can use is create sweep, and that profile, and then the path I can select as being the outside edge. I don't know if you can see that you can see it in red at the moment. What it's now done is added that all the way around the outside of that edge. So very quickly, if I click on join, what that's done now is it's given me a continuous loop In fact, I've selected new body and I'll show you. So what it's done is if I hide that lower, it's created the overhang for me based on that profile. So again, really kind of quite useful for when you as you're designing and you're thinking about overhangs, you can use a sweep to wrap around, and then all you've got to do is modify, combine the main body with that, and it becomes then part of the plastic. So when you're then printing, when you're then printing, if I was printing this like, you know, straight up, what I'd have is that overhang built into it. So again, it's just I think as you kind of start to go through all of the different tools, it's just playing with the different tools and looking at what you can use them for and when's appropriate. So I'll just undo that to get back to
Oh, look at you.
So after being like, oh, I'm available both days. Now they're like, okay, good. What about tomorrow?
hang on a sec, I think.
So,
Fold these up. I'm just gonna.
Oh, there we go. Sorry. I just muted that. Anyway, recorded for posterity and will be on YouTube later. Yeah, so does that make sense on the sweep? Yeah, brilliant. So, and again, you know, part of the challenge with Fusion is getting the sketch in the right place in the first instance. So if I look at this leg, where are we? Yeah, so if I look at this leg pipe, it's going down and back and round. So what I'm going to do, I'll just remember where it is. Go to the left. I want to start to sketch somewhere about here and then bring it round and back. So what I'm going to do is use construct. This time I'll use something called offset plane. So offset plane, all you do is highlight an area of the plane and any of the plane sizes. And I want to sketch is just that little part there. So I'm just going to pull that back a little bit. Actually, what we'll do first of all, as I said, when you first create planes, they're not always as long as you want. So you can grab hold of any of the edges and pull them out. But I want to kind of, if you look at it from the front, I want to start sketching around about there. So what I'm going to do now is that plane I've just created. I right click on that and click on move. I can just now shift that plane in again to exactly where I want it to be. So I'll pop it into about there. I should put it in about there like that. And then that lets me sketch that first part of that pipe in the right place. So I'm going to go into sketch mode on that. Now I'm on that plane again, and again I'll use. I'm going to use Spline and just see if I can roughly get where I want. Something like that. So, and the other thing with Spline is, I think I mentioned this last time, you don't have to get it right first time, because once you've done your spline, you can go in and you can start to drag some of the points around. So I can reduce that little bit of that kink on there if I wanted to. If I click on any of the points, I can adjust the acceleration of the actual curve. So I can get it just around about where I want it to be. Just pull that out a little bit like that. There we go. So yeah, I'm happy with that. And then again, if I then look at it from the front, I can see that I'm going to drag. Let's move these points yet again. So whoops. What's happened there? I've obviously dragged that right down to there. So let me just undo, get back to how we were. There we go. Right. So what I'm going to do now is right click, move. And I'm just going to move these points. When you first start moving these points, it looks like it's going to make a right mess. But if you just pull them across, there we go. start to get it to follow that pipe there. There we go. Yeah. Why is that doing that now? It's, and then didn't exactly go to plan. Let me try again. Move. So let's drag these points out to there. Drag that point out to there. Get that point out to there. Might just and okay, and then drag that point out to there. Escape. Oh, don't hit escape. I hit escape then. Sorry about that. I'm just going again. There. There. And there. Okay. And then what I'll do is I'll just grab these. Just, you know, just smooth out the angles a little bit then. Move that one to the. Move that to the. There we go. That will do. Okay. So what I've got now is a pipe that's following it from that side, and then I've also got the same angle. So it's roughly the sort of size and pipe that I want. And then if I look from the bottom, what I'll do is I'll just sketch the profile then of the pipe on that starting point there. So the profile is just going to be a circle. I'll make it about that big. Finish sketch, and then oops, I missed that. I'll just right click on that and move it so I can move it back to, so it's got to intersect where that sweep is. Okay, highlight that, and then I'll do a create sweep and select that as a pathway, and put that as a new body. And then what I've done there is I've actually created the pipe then that's roughly the same as the one that you can see on there. Now, as you can see, it's considerably thinner than I want it to be. I'll just see if I can press and pull this one to make it a little bit thicker. No, it won't let me pull that. So let's try and make a slightly bigger circle. But hopefully you kind of see. And all I'm going to do is delete that body, delete that center circle, and then I'm just going to recreate it really. So create sweep. And select that as a pathway. There we go. And a new body. Make it a little bit thicker. There we go. So that's your pipe. And then obviously you just repeat that on the other side. Delete my sketches as we tidy up, and effectively that goes in. I think we'll mention last time as well that this is about 1.7. 2 millimeters thick, so you could actually just use filament for this one and drill a couple of holes in there. So both kind of works. But yeah, so that's the sweep command. And then, to be honest, the rest of the details on the Gonk is just a matter of continuing to model. So, you know, drawing the squares, drawing the circles, pulling, extruding. And it's more than around being creative in the way, like we did last time, about actually getting everything ready for printing, making sure that you've got overhangs that will print, you know, etc., etc. So, again, I will just stop there. Any questions, thoughts, observations, or anything that you'd want me to go over? Are we all okay so far?
Yeah, one, Michael.
Yeah, go for it.
Yeah, so kind of what you were just coming up there was something I had run into a few times now, where you've got a body and you wish it was like a little bit larger or in a different position. And like in general, I've had to kind of start over instead of being able to like adjust the profile or slide it. And kind of like the same with holes. Like I've placed holes, but I've decided, oh, I want, or like a body to extrude part of it, and then I want to move that later. Is there a way to do that once the bodies are created and you've lost the sketches and stuff?
There is, yeah. So if I'll just do something quickly. So I'll just model block to play with. Yeah. So start with holes. So if I was to create a hole in here, which is that big, right the way through there. So I'm just going to cut a hole. So the first thing with holes is holes can be moved around in the same way as bodies can be moved. So if you right click on a hole, once you've got it selected, you can actually move that hole around. So you can shift the hole to wherever you need to. If you want the hole to be smaller and larger, you can press pull to reduce the size of the hole or to increase the size of the hole. And likewise, you know, I tend to use things like, you know, press pull all the time, really just to adjust the size and various dimensions on it. Now, it works very well when you're just doing it with squares, but then when you start to introduce more complex models, like you've got fillets on there and things like that, what it can do, it can operate slightly different. So this is working okay. If I try and press and pull fillet, so you can see what happens then is it does the best that it can do to adjust the model that you're actually wanting to in whichever direction you want to kind of do it. But the more complex the model, the more things then start to be interlinked, even in direct mode. So like I said, if I'm trying to alter that curve, you can see it alters all of them. But most things can be moved around. So but if it's got I'm trying to see if I can get it to, yeah. So again, you can see I've just put a chamfer on that. So what it's then done is it's done the rounded bit on that corner. So the more you kind of add to the model, the less flexibility then you've got when you start to pull. But generally, you can push and pull most parts around. Have you got any specifics that you wanted to? I mean, I don't know if that what I've just gone through there was useful, or whether you'd hit other challenges that you couldn't do things with.
It's definitely helpful on the holes. I guess if you want to go back to the Gonk for a second, I could see if I have a better example. So like if we the body that you've got there for the greeblies on the tray, if that's already, is any of that recessed? I guess like if there was like a piece that was recessed and you wanted to move that, but you had already extruded it into the other body, I guess. So something other than a hole.
So yeah, if you pull in, you can pull it in and out. Do you mean actually physically move the recess?
Yes.
Right. So if I hit move on there, that's where it won't let me move the recess. Is that what you mean?
Yeah.
Yeah. So I mean, in that case, a couple of things you can do is you can press the shift key and select more elements around. So, because what it's trying to do is it's trying to move just that back plate with it, but it kind of realizes that it's got all of the recess planes and the fillet planes and all of that kind of stuff. So sometimes if you press shift key and select more of it like that, and try moving, it can do. Let's try to see what happens. Yeah, so there you go.
Okay.
So
Cool, thank you.
yeah, so that's one thing. I mean, what the other thing that I'll do sometimes is if it won't move at all, I'll literally drop a square around it, do a modify split body, literally cut that out, and then just move that whole piece to where I want it to be. So I can pull that down to there, for example. And then what I'll do is just pull that top bit so it just overlaps again. And if I hide that piece that I've just cut out, I can then pull that bottom piece. It's a bit of a workaround, to be honest, but you can do something like that and then modify and combine them back again.
Well, so in that case, you're kind of sliding it around, making holes and then filling them and sort of matching things back up.
Yeah, so
Okay.
all that if you've got something with a load of complexity and detail, all you've got to watch out is that on the inside you've got enough room to play with it, that you don't end up hitting a corner or something like that. But I'll just step through that again. So what I did is I went into sketch mode on that plane that it's on. I drew a square around it, so it's fairly close all the way around like that. And I'm using that square then to cut out the piece that I want to move. So modify split body, highlight that middle section like that, click OK. And now that's obviously a cut out separate piece. And then I can move that wherever I want to move it. So I can move it up a little bit and across a little bit like that. And then when I've done it, all I'm doing then is these inner faces here, which is the old hole. I'm just using the pull command just so that everything connects back up again. That makes sense. That. Just pull. So it just saves you having to sort of recreate the whole thing again, and then modify and combine this and this again. Is that helpful?
Yeah, thank you very much.
Cool. Good. And
Hey, Michael, a couple of quick questions.
Yep.
So your primary use of planes is to be able to sketch in space. Is that how I'm understanding it?
Yes. Yeah. You can use planes. Well, you can actually use them for quite a few different other things, but that's what I've been using for them so far. Yeah.
Okay. And the second one is for when you had the 90-degree overhang on that edge, when you fixed it, is that going to be a part of the print? That could be removed later, or is it going to be permanent when you created that to fix the 90-degree overhang?
The one that I did underneath here.
Yeah. Is that going to be permanent part of the print, or something that's removable?
It's a permanent. If you do a body combine, it's a permanent part of the print.
Okay.
So if I do modify combine, what it's doing is it's taking that piece that I had around there and combining it with this body to make it actually part of that whole body.
Okay. So it is part.
So it is a
So, like,
permanent part.
are the little triangle supports on R2 object that you created in Fusion and then duplicated around, or is that a feature of Fusion somewhere? The ones you can snip off.
That's effectively I've created those. So again, if I do, I'll just quickly show you. So if I do mid plane I'm just getting a mid plane to give me something to sketch onto. Okay. I'll show you how we did those. So you pull that like that, and then I'm into sketch mode onto there now. So if we're just going to project, oops, great, project. Project, there we go. I'll just project that and that. It's fine. Yeah, so they were the little plates that went something like this, I think, and then there was a I did a couple of little cutouts so they weren't stuck directly to the plastic, so they've got a bit of a latch, and then I put a little bit of a gap at the top. They were measured, obviously. I think it was 0.4 mil or whatever at the top, which was a gap for it, and then that gives me one. So I might make that. Make that point. I'll do it 0.8 mil wide. It's a new body. So then, yeah, so I've modeled something like this. And then what I would use then is create and pattern. So I'm going to create pattern. I'm going to create a rectangular pattern. And I'm going to use the very edge there as the guide. So what I can do now is, as you can see, that's moving. If I wanted to click it onto symmetry, I'll move it to there. And then I can choose how many of those I want, 4, 5, 6, 7, 8, 9, however, like that.
That's awesome. Thank you. Andrew, does this help kind of with what I feel like what your question was getting at too?
Yeah, because I wanted exactly. Is that Jim? Yeah. That's what I was trying to figure out, because I want it to be removable where I can still have the 90 degree, but just for printing purposes, have it to where yeah, got it. That's good. Thank you.
Yeah, so you can do, and tolerance is, you see, if you use a slicer to generate supports, it will create an empty gap between the layer and then the support, but that empty gap is dependent on the layer height that you're printing on. So if you're printing at 0.2, it'll typically create a 0.4 layer height. But if you're printing at 0.3, it might give you 0.6. So it's got a couple of layers where you're not printing, which gives the plastic enough time to cool, so it's not going to stick to the next layer. So when if you're doing these, what I tend to do is use a 0.4 gap. I tend to, the built-in supports, I'll tend to use a 0.2 layer height as a start, probably do a 0.4 gap. And then likewise, you know, it's a little bit of trial and error, but when you're doing these little tabs that are sticking into the body, you want them to be big enough to hold, but small enough so that you can cut them out, if that makes sense, with little clippers. So, you know, you can kind of play around with those a little bit.
So the width, the widths are closer to allow for better bridging. Is that right? Especially when you're coming across.
Yes.
That. Yeah, gotcha. Okay.
Yeah, you want your width to be to try and give that. The closer you are, the less you're going to get sags in between each one.
Right. Thanks.
And a lot of it's trial and error to see what works on the particular model that you're printing. But these are, I mean, as we've seen on the some of the R2 ones, these are quite easy to cut off with a pair of them little side snippers anyway.
Right. Thank you.
So yeah, so the pattern command is really kind of quite useful. The other one you can use is pattern on the path, which is, whereas before we just did it in a rectangular shape, if you click pattern on a path, it'll allow you to do a little bit more of a complex path. So as you can see there, it's now got, there we go. This one's now allowing me to go around the corner as well, albeit.
With those patterns, if you modify the original object, will it update the rest of them?
Not in direct model, no, it won't. Okay. So you mean if I was to put these in, so I was to put those supports in like that, click OK, and then I was to pull this face out.
No, I mean more if like let's say you wanted the triangle to be slightly taller, could you update one of them and then it would replicate the rest within that pattern?
Okay. You mean if I was to pull
Or
this
if you
up?
put a hole in the middle of that or so, like if you did something to
Yeah.
one of the triangles, does it copy it to the others, or are those each their own item now?
Yeah, you can see as I'm pulling one that they're all the other two are pulling. Can you see that?
I think I'm getting lag where I don't, but I believe you.
Yeah,
Yeah, it is. It is.
It is.
In-
Yeah.
Oh, there it is. Okay, cool.
Yeah,
Yeah,
when
it's
you
cool.
when you mirror an object or you create a pattern of an object, it tends to link the objects. Now you've got to. I've been caught out with that, to be honest, because what I've done is on R2's on the booster panel, details at the side, the booster covers, I've pulled one side back for by 37 mil or whatever for the long and short legs, and then I've gone to the mirrored one and pulled that back 37 mil. And what I've actually done is pulled it back to, what is it, 74 millimeters, because I pulled it back twice because it's affected it twice, because if you do it on one mirror, it actually affects the other one. Does that babble that I just said make sense?
Yeah,
Yeah,
absolutely.
that
That
does.
answers
Yep.
the questions for sure. Thank you.
Yeah, so you've just got to keep an eye on the models as you're kind of making changes, particularly where you've got patterns or you've got mirrors, because it can affect more than one. And then the other thing to watch is making sure that you combine all the pieces that you want to combine before you then start to expand to export your STL. So at the moment, the body's not got those supports combined to it, so I'd have to use modify combined to get them to connect together. So I'll just delete those. And then once you've got your body ready, and so I'm not going to go through modeling all of these because we're using a lot of the similar ones. Once you've got the body ready, then right click and save as mesh, exports it then ready for STLs. So I think I don't know if I mentioned this last time, but the format that in the last update, Fusion 360 used the default format now of 3MF, which is it's a bit more of a sophisticated mesh model, and a lot of slicers will happily load a 3MF mesh as much as an STL. But if you are exporting, so you want lots of people to use it and for maximum compatibility, then you need to drop down and reselect STL. So it's just a gotcha to watch out for on there. I think the 3MF, I was having a read through, it's got a few extra features. It holds the scale a little bit better than STL. STL is quite an old-fashioned one, but it works for what we do. You've also got refinement. So you've got high, medium, and low on STLs. And when you're exporting for print, that's the number of polygons that you've got, or the number of triangles that's actually on that model. So if you do a low refinement, your triangles will be a lot bigger, and you'll be able to see the faces actually on the print, particularly on things like domes. You can go medium, you can go high, or you can go to custom. And then in custom, there's a few different settings like these surface deviation, normal deviation, maximum edge length. So you can play around with these, and what they'll do is they'll increase or decrease the resolution. And if you're wondering what they, do you increase or decrease a number to increase or decrease the resolution, you can literally select your high, medium, and low on there and see how those numbers change. But that really does affect the quality of your final print. So something just to watch out when you're exporting to STLs. If that makes sense.
What do you typically use? Do you use custom, or you just go with, how do you do it most of the time?
Yeah, I at moments I'm running it on custom because the high still doesn't give a high enough resolution for the stuff that I wanted, particularly if you on things like single print domes, or really the really big models. I've got one on custom. So at the moment, I've got a setting that I'm happy with, 0.03 surface deviation, 4.45 normal deviation. So these are just ones that I've played around with to get something that works for me. The high works pretty well, to be honest, in most cases. It's just that what I was finding is, particularly on the single domes, I was still being able to see some of the facets. So I've been playing around with it a little bit. It does mean that your export's larger, so the actual STL files can be quite large. And I think that was very noticeable on the greebles on the little Drinks droid. So the little greeble at the back was ridiculously high res, and it was ridiculously large file. And of course, then people were struggling a little bit when they loaded them into slices, so they'd end up just touching that down a little bit. But you've got quite a bit of control on there to play with it. And then I think we covered this last time as well, but obviously that you've got the file save, which saves to the cloud. So Fusion is a cloud-based system, but you've also got the export, and export lets you then save all of these files to a local file on the .f3d format, which is Fusion format. So if you don't necessarily trust the cloud, or you're worried about losing files, you can also save to these things locally. Okay, and that was pretty much it, I think, to cover on the Gonk. Anything you want me to cover specifically, or anything that you want to dig into? More questions?
Hey, Michael, one more for you, and then I think I'm okay.
Yeah, go for it.
You, in the beginning, you mentioned about the detail about on the Greeblies. Well, you said if you had fine lines, you would use like a 0.6 millimeter for detail. Is that something that you set in the, where would you do that in the Fusion? How would you work that out?
No, what I was referring to is if I was to create a line, sort of like a thin line that detailed the panel, from experience, anything, so if I put 0.6 on there, so that, if you can see that, that's 0.6 millimeters wide, that block that I've created. And then if I click on finish on that, and then I right click, press pull, minus 0.6. So what I've created there is a little groove that is 0.6 deep,
Okay.
and 0.6. What I was kind of saying is that I wouldn't go much below 0.6, because what you've got in the back of mind, what you've got to imagine is that your nozzle is 0.4 millimeters. So it's quite a big lumpy crayon thing that's drawing this almost. So what you want to do is not go dropping into 0.1 millimeters, because you just won't see it with the nozzles that you're actually printing on. And even in resin printers, you won't really see that. So it's just making sure that you exaggerate the detail enough.
Got it. Yeah, I missed that. Thanks.
The panels in R2 are 1.54 about 1.5 millimeters wide and 1.5 millimeters deep. The holes for the panels are huge things, particularly when you first model them. I thought, oh my God, this thing's going to look ridiculous, but of course it looks fine from a distance. And that I tend to use that 1.54 again as a standard way, as a standard kind of tolerance for doing panels on full size ones, because that's what R2 uses. The other thing quickly to cover, which I'll unless anybody's got any questions, just fire them out. The one thing
real quick with that recess, that's like a really simple example of kind of what I was asking earlier. So like that one you just made, if you wanted to like slide that to the right or rotate it 90 degrees, is that something?
Yeah,
you can show real quick.
So again, because whatever you highlight is what it's going to try and move. So if you're going to try and move a whole recess, your best thing is to hit the shift key and select all the facets that are in that recess.
Got it. Cool. Thank you.
Yeah, and then right click and do move, and then you've got more chance. Now, The other important thing is you've something that I use all the time is this thing here called set pivot. So by default, it's put the pivot in that corner there. If I click on set pivot, I can now drop that pivot anywhere. So if I'm moving something here, I might want the pivot to be roughly in the middle. So I can pop it there. What it'll do is it'll shift that pivot point to there. And when I've finished, I click that little tick box. So now the pivot is the place that I'm grabbing these little arrows is in an easier place. So now I can drag it left and right, up and down. I can rotate it. But the reason I can do that is because I've selected all the different facets that's on that object. So if I just selected the back without selecting the outer ones, it won't let me do it, because what it's doing is it's saying you want to move the back, but you actually want to keep all of these bits that are cut around it in the same place. So I don't know what to do, so I'm just going to leave it there. Does that make sense?
Yes.
Yeah, thank you. Kind of tries to keep it as a closed object. Then.
Yeah. So I mean, Fusion is really quite clever. I mean, but you know, if you want to move something, you say you want to move this whole thing here, you could actually just go around, press the shift key and select absolutely everything in there, and it would let you move it. The other thing that I tend to do is just use split body and use that back plate as the splitting tool, which then effectively creates this piece here as a separate object. So I can again, similar to what I did do before, where I just cut stuff out. And that's why, again, I quite like using direct modeling, because I could just cut stuff, move stuff around, and then just use combine again to put it back together.
Yeah, that's really
Great.
very helpful.
Yeah, that's cool.
Yeah. The other question that I get asked a lot about is how you join, or how you cut objects for joining, particularly if you've got a smaller printer. So
Yeah, definitely.
yeah, so this is I'll show you on a really simple one, but you know what I quite like dovetails, to be fair, because they're quite a neat way of doing it. So what I'll tend to do is I'll draw a line to cut it where I think is appropriate, and then what I tend to do is just draw a line out. And again, I use the mirror quite a bit just to save me having to get everything perfect. So I'm just going to mirror that line. I'll just delete that middle one. So that's effectively now giving me a sketch for the dovetail. So if I modify split body, I'll cut it in half first of all, bring the sketch back, modify split body, this top bit, and oops, I'll then select the two parts of the dovetail. Okay, so now I've hide the sketch. I've now got three pieces, this piece, this piece, and this piece. So what I can do is modify, combine this with the inner part of the dovetail. And that, what I've effectively then done is split this into two parts with a little dovetail that connects the two. Now, if I print this, you wouldn't have a hope in hell's chance of actually getting that dovetail to fit together, because the tolerances would be too much. So what I then do is hide one side of it, highlight all the faces on that, and then just use a press pull command to do minus 0.25. About quarter of a millimeter gap gives you a fairly tight fit, but it will actually fit. So you can see now that there's a 0.25 mil gap between this piece and this piece, which means that dovetail will go in. If that's a bit too tight, you can always then just pull it back at another minus 0.05, which will give me a 0.3 millimeter gap then, which I know is going to be fairly comfortable. And 0.25 to 0.25 to 0.35 is what most people use for something where they want a good solid tolerance where it's going to fit together. If you go 0.5 to 0.7, that's where you've got parts that will move. You know, if you're trying to create something that's where you want it to actually move or slide, then, you know, 0.5 mil to 0.7 mil will give you enough space. And then things like wheels and bearings and tolerances, I tend to use 1 millimeter gap then for stuff like that. So it's just a matter of playing around with some of the tolerances that's on there.
So at that 0.25, you should be able to get really nice friction fit.
Yes.
And then you use like plasti struct or something like that, and then it'll go right into the cavity and just weld it all tight together.
Yeah, exactly.
Okay.
So, but yeah, 0.25's, you know, kind of the default one really that I use.
That is very helpful because right now I have a smaller printer, and
now it does rely on you having access to the Fusion files or the step files. So there's the files that we're using here, obviously the Fusion ones, and they create the object. So these are not a mesh. If I'll show you the difference actually. If I insert mesh, so if you were I'll just grab one of these off the lid. There we go. So what I've done here is I've pulled in an STL file. So what I've got here is this is a solid body, so it's part of Fusion. The step or STP files tend to be this format. So if you've got access to an STP file, it will come in like that. If you pull in a mesh file, so you pull in an STL, it doesn't know the shape of that object at all. All it knows is each individual triangle. So with an STL file, you can't draw on any of these faces. So if I click on the sketch, it won't let me select any of these faces. So a mesh file is very limited things that you can actually do with that. You actually need access to the original Fusion files.
So is it similar to like an STL file and a G code file? You know, the relation, you know what I'm saying? If that makes any sense.
Yeah, sort of. The step file or the Fusion files, these are the parent, if you like. So this is the original reference. And then when you export whenever you export it to an STL file, then what the software then does is create all these little triangles in the same way as if you take your STL file, it creates the G code. But with the mesh, with the STL file, there's very little you can do to edit this. It's not it's not easy to put these things. So what you really want is to have access to the original Fusion files or a step file, which is kind of why I tend to throw all of the Fusion files up for sharing as well, so that people can, you know, do their own custom cuts. Because otherwise, it's a lot harder to do it with mesh.
Gotcha. Thank you.
Yeah. So yes, that's dovetails. There's come out to sketch. The other thing that the other method that I've been using quite a lot recently has been the using the little 10mm by 3mm grub screws or set screws, and for joins. So I'll just quickly show. That's 11mm. So what I do is actually make a hole. So we've got 2mm. I've actually got a few of these set up, but I'll just show you roughly. Great. Rectangular pattern. And then, so I was trying to find a way is to do an edge-to-edge glue or an edge-to-edge fixing that would be fairly solid. So that's where I thought actually the little grub screws or set screws are readily available, and I could use those to create holes. Oh, sorry, I could use those to glue an edge to edge. Lost my bloody sketch now. Where's that sketch gone? There we go. So I'm trying to do two. I'm trying to talk and design at the same time. Never a good thing. All right, let me do finish sketch, create revolve. So what will become apparent when I've done this? So one of the, as we know, there's no perfect plastic. I like PETG, it's great. But what PETG does is it's really difficult to glue. So I came up with the idea of using the little grub screws, which were 10mm long by 3mm in diameter, and then using 2-part epoxy to glue them into a hole, which also got ridges on the inside. So what that means is that the glue is acting like a mastic, so it's filling all of the gaps in between, and it's wraps itself around the thread of the grub screw, and it pushes itself into these little holes. So it actually creates a physical fix as much as a glue fix. So I do use, I've got one of these that I model that I just use to make holes now. So and then rather than using things like dovetails on an edge to edge fix, what I can do is pop these in. I'll show you what we do. So what I tend to do is pop them into the body, just embed them 6mm either side, and then use them to create a hole in the actual model. So again, create pattern, rectangular pattern. Let's just highlight the direction on there and then move that along. So I'll create sort of 3 of them. And then modify combine. And what I'm doing is I'm combining these together, but using cut. So what that's done now is it's created the little holes in there, which the grub screws will fit in, perfectly. And then what I do is I repeat it on the other side as well. So modify, combine, 1, 2, 3. So what that will give me, if I just inspect, so point through. I don't know if you can see that, but it gives me, this is just a sectional analysis, but it just gives me a hole then with little ridges on the inside. So when you put a grub screw in there with some 2-part epoxy, the 2-part epoxy actually goes into all of those ridges on the inside of there, and will go into the ridges on the grub screw. So it creates a physical glue as much as just a glue that's holding it together. So that's another kind of joint technique that I use on quite a lot of the models. But when you're trying to get a nice, edge to edge fixing, if that makes sense.
Michael, just on that one. So you screw into one side of it, and then the other side is a push fit?
No,
right?
the holes are big enough so it just pushes into both. So we're using a 3mm diameter in about a 3.3mm hole.
So, right, okay. So it's literally just a peg almost.
Yeah, I mix 2-part epoxy glue, and then what I tend to do is dip the grub screw in the 2-part epoxy and push the epoxy into the hole, and then do the same on the other side. So what happens is the epoxy then fills that hole in the inside of here and wraps around the thread as well. So it's really kind of embedded into the ridges.
Got you. Okay, understood. Thank you.
Yeah. So and there's all sorts of different sort of creative ways you can do that. You could make one side on this smaller than the other side, Jim, to be honest, and then what you could do is screw one side of the grub screw in and then use glue on the other side.
Yeah.
So there's all different ways that you could kind of do that, but it's it's different ways of experimenting. And
Yeah, I saw on YouTube there's one gentleman that's putting together a chopper. He's got like seven different parts, and he's showing it very detailed. And that's what he said. Sometimes it's because of the printer differences. Some of the holes will be much larger than others. So he's got his Allen key there, and he'll screw some of them in, and some of them are a little bit larger. But he said that it makes an excellent mechanical fit, and it works really well. He's using new patterns. I forget what his name is.
It's Andrew, I think it is.
I believe so. Yeah.
Yeah, so it does do a really good mechanical fit. One of the challenges with designing is the tolerances of everybody's printers, because the squish when you print something, how much it comes out either side, whether it's over extruding, under extruding, so you just got to find a happy medium. It means some people will have to sand and some people will have to glue things in, but yeah, it kind of works. Brilliant. Right. Well, I think hopefully we've covered enough, and hopefully that gets you started on modeling. And I mean, in theory now you should be able to, as we set out really, which was to model a gonk that you could then print in whatever scale you wanted to. And fingers crossed everybody sort of feels confident enough to be able to do that.
Yeah.
Good job. But by chance, what's the actual height of? I haven't looked it up, but what's the height of the Gronk full size? Is it? I don't know how many meters it is, but I never looked it up.
Yeah. So soon measure it for you off that one, I think, can't we? So how high is Anthony Daniels?
No, this is this is 1-to-1. Is this a 1-to-1 that you're doing here, or is it?
No, this is one. But this I did this to Sideshow.
Okay, yeah. So what's the big full size one? Yeah, I don't know how tall he is. 5 foot something.
I've got 1.75 meters. So what I could do is go into Canvas and use Calibrate again.
Yeah, Calibrate.
To assuming that height for Anthony Daniels is correct. That will be 1,750, which is 1.75. Do that. There we go. And then just double check his height. So I'm just going to draw a line, which is 1,750, and then I can draw a line for Gonk. So it's just, it looks like it's just over a meter, 1.162.
That's what I was thinking. Yeah.
So yeah, what's that? 1 meter, 162 centimeters. Whatever that is in your strange American dialect of measuring things.
Strange. Thank you.
That's my next project.
No, actually, if you've got document settings on there, you've got units, millimeters. You can change units at any time. So if I want to put that into foot, okay, I can now measure that, and it's 3 foot. It looks like it's 3.8 feet high. The Gonk.
That's pretty big.
Yeah,
that is actually 3.8.
Yeah.
But if you look at it, I mean, it is kind of coming to just below the chests of C3PO on that one.
Yeah. I actually joined a Gonk club, and they're using the plastic storage containers for it, and they got some pretty big ones, and they're very detailed. But
there's well, I mean, we've modeled the Gonk for a smaller one, but you wouldn't necessarily print full size one because you just use a plastic container one.
Yeah, but they generally don't move around. That's what's kind of cool with the one I'm working on.
Yeah. They're I don't know if you joined the Drinks and Droids thing last night, but we had Michael on who's doing all the sound effects. So I think he's due to release a Gonk version of it.
I'm kind of stoked about that because that's what I'm working on the mini right now. And it's like, okay, can I just steal all those files and
yeah, no, it's he's doing some amazing work on that on certainly on the Astromech stuff, but bringing that out to Gonks and some of the other droids would be fantastic.
Yeah,
Cool. Right.
Come on.
I think we've done. Any last questions, or are we all happy?
Thanks for your time and sharing it, Michael.
Thank you. Thank you very much. Appreciate it.
Yeah, really.
Well,
appreciate it.
I'll probably do a couple of weeks gap, and then what I may do then is do something that's more mechanical. So, you know,
Yeah.
start doing some gears and
Okay.
some wheels. And
Great.
things and
I was going to
bearings.
ask that question. Yeah, that was good.
Yeah, because I just think, I mean, this gets you the basics, but then what I'll do is start just getting, you know, so it's like the little baby astromechs that we did, maybe something like that, where we're bringing in some real life servos and then work out how we model it so that we can start getting things moving.
So we can take some of the Greeblies off the R2 head and put them on.
Yes, exactly.
That's yeah, to help it easier to finish. So, but
Thanks, Michael.
Thank
Perfect. Okay. Cheers, guys. See you
Yeah.
all soon.
Okay, everyone.
Thanks.
Bye.
Bye-bye.
Bye.